Welcome back to another video. Today we're going to be talking about related accelerations and a concept that will be very important in solving a lot of different types of problems. Okay, the problem says the disk rolls on a circular surface with a constant clockwise angular velocity of 1 radians per second. What are the accelerations of points A and B? Okay, let's write out our givens. So they told us that the angular velocity is 1 radians per second. And then it's going to be negative because it's in the clockwise direction. The angular acceleration is going to be 0 because the angular velocity is constant. The radius of the circle is 0.4 meters. And the radius of the circle upon which it's rolling around is 1.2 meters. They're asking us to find the accelerations of points A and point B. Okay, so points A and point B, their motion is kind of complicated, but if we let the center of the circle be 0, we can use that to find the behaviors of points A and B, because A's motion is simpler than point B's and A's. As you can tell, they're moving in a circle around a circle. So, for a general point, P, let's write out its equation so that we can just replace it, P with A and B at the end. So, related accelerations for planar motion, you would use this equation. So this is for 2D motion. And then we know that the angular velocity is constant, so that is 0. Let's rewrite this, taking away that first and only cross product. Great. Okay, so now let's write what we know and what we don't know. We don't know the acceleration of point O. We know those two terms based on givens and geometry. So we need to use another, well, let's star this first because we're going to be coming back to it. Now we need to think about what the acceleration normal to a circular motion is, and that's that equation. Let's rewrite it in terms of our problem. So with the velocity of O, because that's the point we care about, that's moving in a circle, add those radiuses together, and it's going to be in the negative j hat direction, because if you look at our coordinate system, y is pointing out outside the circle, and negative j is towards the center of the circle, and normal acceleration is towards the center of the circle. So we don't know what the velocity of O is, so let's use the related velocity equation with respect to point B. And then we know that there is a special trait about point B. Point B is actually, we're assuming that the disk is rolling without slipping. So point B is stationary with respect to the surface. So it's going to be 0. And I'll write this out so that we don't forget why it's equal to 0. Okay, great. Now we can move forward because we know the angular velocity and position vector from B to O. So 0 plus negative 1k, because that was given to us. And from B to O is just the radius, and it's going in the positive j hat direction. So if you take the cross product, that's what you get. So now we know the velocity of point O, so now we can know the angular acceleration, or just the acceleration of point O. So let's plug that in, along with both of our radiuses that they gave us. And then solving that, we get this term to be negative 0.1 j hat. Okay, so now we know the acceleration of point O. That's the only unknown that we have left in that starred equation up above right here. So let's replace P with point A. Perfect. Okay, so now we can solve for the acceleration of point A to be negative 0.1 j hat minus negative 1 squared, so that would just be 1 minus 1 times the position vector. And then the acceleration of point A is equal to negative 0.5 j hat meters per second squared. And I'll go back and correct that minus sign with the angular velocity in a second. Okay, so now replace P with B to find the acceleration of point B. With respect to O, the acceleration of point O is going to be the same as before, negative 0.1 j hat minus, and then let's put a negative sign in there with the 1 to be negative 1 squared. And I'll go ahead and fix it up above 2 right in there for acceleration of A also. Okay, so plugging in the position vector from point O to point B, we can tell that that's the only thing in this general equation that changes. So point O to B is going to be negative. So that's going to be negative, that's going to be positive, and that's what changes the accelerations of these points. So the acceleration of point B is equal to 0.3 j hat meters per second squared. So that is related accelerations, taking into account the special behavior of the non-slipping point B.